Hi, I'm Jeff Wilson, and this talk is about infotainment systems, and in particular, why generative AI is dangerously unsuitable for infotainment services. Of the four applications for conversational technology, infotainment, customer service, home robots, and conversational AI systems, infotainment is seemingly the easiest of these applications to implement. As in the general case, there is a unique speaker, the driver, who is also in a unique physical environment, the driving seat of a car. However, whereas the other three applications essentially only pose risks to the user, a badly designed infotainment system puts not only the driver, but also other vehicles, pedestrians, and especially children at risk. In case you think this is overstating the case, one only needs to reflect on the fatal crashes of the two Boeing 737 MAX passenger aircraft, almost certainly due to a change in the pilot interface that was counterintuitive and behaved in a very unexpected way. I first started talking about cognitive overload in 1981, when I would demonstrate that digit strings with unnatural pitch contours could be clearly heard, but, seemingly bizarrely, the numbers could not be remembered. Cars with driver assist software seem to already have some dangerous attributes, and you can read about phantom braking in my book Precise AI. If hallucinations were to be added to an infotainment interface, then this would seem to be an unbelievably dangerous design choice. This would not principally due to any physical aspects of such a system. The real danger that such systems would pose is to a driver's ability to concentrate, and cognitive overload would be a real danger. The only way to avoid the driver overload associated with such problems is to implement an infotainment system that is well understood with a well-designed mathematical model, i.e. precise AI. I must also add that as context is so essential for human-level understanding, and as context is held in cognitive memory, it is worth reminding ourselves that infotainment systems will always be cheaper to develop, more verifiable, and hence more reliable, if the cognitive memory representations are invariant and can therefore effortlessly handle a multilingual environment. I have been developing such cognitive invariant representations for almost 20 years, and such representations are one of the assets of my company, Precise Intelligence Limited. The key representations are now well understood, but there are always mopping up activities focused on ensuring the best possible representations are used. One design issue is that if there are some n-to-1 mappings, how best one can retain the original surface form of a sentence. This thought reminded me of an aspect of German that seems odd to an English speaker, which is that whereas in English 9:30 means 9:30, in German the equivalent phrase 9:30 means 8:30. As I record this on the 30th of March 2024, Google Translate gives 9:30 as 8:30, which is the correct translation. In contrast, my Apple Translate app gives 9:30 as 9:30, which is incorrect. At this point, the question that immediately comes to mind is not as to why, but how. Such issues do not arise with precise AI.